Question 4a. Evaluate the definite integral from x equals 0 to x equals pi over 4 of cos x sin squared x dx. The following are the marking guidelines for question 4a. For 1 mark, we have correct primitive or equivalent merit, and for 2 marks, we have correct solution. The integrand cos x times sin squared x dx can be written as cos x times sin x to the power of 2 dx. Now we can apply the reverse chain rule since the first derivative of sin x is equal to cos x, and we're multiplying this sin x to the power of 2 by the derivative of the inner function cos x, which means that the chain rule must have been applied to the primitive function to end up with cos x times sin x to the power of 2. So we can integrate this using substitution by letting u equal sin x. We have du dx is equal to cos x, and du is equal to cos x dx, and we get that by multiplying both sides of this equation by dx. So integrating this with respect to u, we're going to replace the cos x dx with du and sin x with u, so we're going to integrate u squared. So the integral of u squared du is equal to 1 over 3 times u cubed, and u is equal to sin x, so that equals 1 over 3 times sin cubed x plus the constant of integration c. But this plus c won't be needed since it's a definite integral we are dealing with. Hence, the definite integral from x equals 0 to x equals pi over 4 of cos x times sin squared x dx is equal to 1 over 3 times sin cubed x from x equals 0 to x equals pi over 4. Applying the limits of integration, sine of pi over 4 is 1 over root 2, so that equals 1 over 3 times 1 over root 2 to the power of 3, and that simplifies to 1 over 6 root 2. The following is the feedback from the Marking Centre for question 4a. This part was done very poorly. Candidates who made the substitution u equals sin x were generally successful. Once candidates had found the correct primitive, they were mostly successful in evaluating the integral. Many did not correctly simplify 1 over 3 times 1 over the square root of 2 to the power of 3.